Module 6, Chapter 3.6, Topics in the Theory of Polynomial Functions, Part 1. Recall the graphs of polynomial functions are continuous curves with no gaps, sharp edges, or sudden jumps. The intermediate value theorem applies to the zeros of every polynomial function with real coefficients. Here are two versions of the intermediate value theorem. Version 1. If p of x defines a polynomial function, and if p of a is not equal to p of b, then for a less than or equal to x less than or equal to b, p of x takes every value between p and a and p of b at least once. What that says is if p of a is not equal to p of b, so you've got p of a as a point and you've got p of b as a point that are not the same point, then for every x value between a and b, p of x, the function, takes on every value between p of a and p of b at least once. Which means if you've got this y value on a graph and this y value on a graph, you will have every value between those on the graph at least once. Now, version 2 says, if p of x defines a polynomial function, and if a and b are real numbers, where p of a and p of b are of opposite sign, then there exists at least one real zero between p of a and p of b. And what that one says is, if you have your same, here's p of a and here is p of b, if p of a is positive and p of b is negative, then there is at least one real zero between p of a and p of b. Now, be careful. If p of x and p of b, actually this should be p of a. Okay, now be careful. If p of a and p of b do not differ in sign, it does not imply that there is no zero between a and b. For example, if this is point A, or if this is p of a and this is p of b, and they're both negative, does that mean that there's no zero in there? Not necessarily, because we could jump back up and cross the x-axis. Now, show that the polynomial function defined by p of x equals x to the third minus 2x squared minus x plus 1 has a real zero between 2 and 3. Well, what is p of 2? That would be 2 to the third minus 2 times 2 to the second minus 2 plus 1, which is 8 minus 8 minus 2 plus 1, which is negative 1. Now, p of 3 is 3 to the third minus 2 times 3 to the second minus 3 plus 1, which is 27, minus 3 squared is 9 times 2 would be 18, minus 3 plus 1, 27 minus 18 is 9, minus 3 is 6, plus 1 is 7. So by the intermediate value theorem, if p of 2 is negative 1 and p of 3 is 7, because one is positive and one is negative, there is at least one zero between 2 and 3. Okay, use the intermediate value theorem to show that each function has a real zero between the two numbers given. Then use your calculator to approximate the zero to the nearest hundredth. So if we're trying to show that there is a real zero between negative 1 and negative 2, we're going to do exactly the same thing. P of negative 1 is negative 1 to the fifth minus 2 times negative 1 to the third plus 1, which a negative to the fifth power would be negative 1. Negative 1 to the third would be negative 1 times a negative 2 would be a positive 2, plus 1 would give us 1 plus 1, which is 2. P of negative 2 means negative 2 to the fifth minus 2 times negative 2 to the third plus 1, which would give us negative 32. Now, negative 2 to the third is negative 8 times the negative 2 would be a positive 16 plus 1, which is negative 16 plus 1, which is a negative 15. So because they differ in signs, we know that there is a 0 between negative 1 and negative 2. Now, how are we going to use our calculator to find that? Well, we're going to go into our calculator. We're going to go into our calculator and do x to the fifth minus 2x to the third plus 1. And let's go ahead and set y2 equal to 0. Whoops, forgot to zoom. Okay, so when we graph that, we get something that looks like that. Now, let me show you something different. If we go second calculate where they intersect, now instead of typing in, whoops, that's not going to work. So if we want to find where those two intersect, the curve and 0, we're going to say second calculate, number 5, enter, enter, enter. And we get an intersection at the ordered pair 1. Well, that's this one. That's not the one between negative 1 and negative 2. Let's do it again. Second calculate, number 5, enter, enter. We're going to move our cursor over between negative 1 and negative 2. And we find our intersection, or our x-intercept, as negative 1.51. Now, just as we can divide real numbers to determine if one number is a factor of another, we can divide polynomials to determine whether one polynomial is a factor of another. Is 6 a factor of 234? Well, let's check it. Will 6 divide evenly into 234? 6 will go into 23 3 times, which would give us 18, which would give us 54. Because it does go into it evenly, we say that 6 is a factor of 234. Now, is x minus 3 a factor of x squared minus 4x plus 3? Well, we're going to divide that to see, and if we get a remainder of 0, then we know it's a factor. Now, let's go on over to the next screen. We can use long division to determine if x minus 3 is a factor of x squared minus 4x plus 3. Okay, so what we do, long division, is x minus 3. So we're going to divide x minus 3 into x squared minus 4x plus 3. Now remember your long division step. First thing you're going to do is divide, and we always divide first terms. So we've got x squared divided by x, which gives us x. So we're going to put our divisor, our quotient x up here. Then you're going to multiply the x times the divisor. So we've got x times x is x squared minus x times 3 is 3x. Then we subtract, which means we're going to change this to a minus x squared, and we're going to change this negative 3x to a positive 3x. So when we subtract, x squared minus x squared cancels. That's a good thing. That's what has to happen. Negative 4x plus 3x is negative 1x. And then we bring down the next term. Then we divide again. Divide first term, so we've got negative 1x divided by x, which is negative 1. That's our quotient. Then we multiply around. Negative 1 times x is negative 1x. Negative 1 times negative 3 is positive 3. Subtract, but to subtract polynomials, we change the sign, so that goes to a plus, that goes to a minus. Negative 1x plus 1x, those cancel, which has to happen. Positive 3 minus 3, this one worked out evenly. So is x minus 3 a factor? Yes, it is. Now, if the degree in polynomial, p of x is divided by x minus k, the quotient polynomial, which we'll call q of x, has degree n minus 1. The remainder r is a constant and may be 0. The complete quotient for p of x divided by x minus k may be written as q of x plus r over x minus k. What that says is this is the quotient. This is what was on top of the division. If there is a remainder, we put it over the divisor. If there is no remainder, then this term goes out. Now, synthetic division is a shortcut used for dividing a polynomial by a binomial of the form x minus k. Now, in synthetic division, all powers must be present, and they must be written in descending order. So, if we wanted to divide x squared minus 4x plus 3 by x minus 3, synthetic division says you take the factor of that, x minus 3, or the root of that, Now, synthetic division says if we are dividing by x minus 3, you take the 0 of that, which is 3, and we are going to divide that into, now this is the highest power of x squared, so there's 1x squared, negative 4x, and a 3. The way synthetic division works is you drop your 1. 1 times 3 is 3. Negative 4 and 3 gives us negative 1. Multiply, 3 times negative 1 is negative 3. Combine, 3 and negative 3 is 0. Because this last piece is 0, that means it divided evenly. And it divides. Now remember, if this is an x squared and you're dividing by an x minus 3, then we drop a power here. So that would give us 1x minus 1 is our answer, which is exactly what we got over when we did it long division. Okay. Use synthetic division to divide 5x to the third minus 6x squared minus 28x plus 8 by x plus 2. Now, when you do synthetic division, you always use the opposite, or you use the 0, which would be negative 2. Then we come over here and say, okay, x to the third is our highest power. So we've got, there's our x to the third, there's our x to the second, there's our x, and there's our number. Drop your first term down. Now multiply. Negative 2 times 5 is negative 10. Combine and we get negative 16. Negative 2 times negative 16 is a positive 32. Combine and we get a positive 4. 2 times negative 4 is negative 8. Combine 8 and negative 8 and we get 0. So our quotient is 5x to the second. Remember, we always drop down the power. Minus 16x plus 4 with no remainder. So that would be our quotient. Okay. Now, the remainder theorem. If a polynomial p of x is divided by x minus k, then the remainder is equal to p of k. So we are asked to use the remainder theorem and synthetic division to find p of negative 2. If p of x is negative x to the fourth plus 3x squared minus 4x minus 5. So the remainder theorem says to find p of negative 2, to do it regular, we do negative 2 to the fourth plus 3 times negative 2 to the second minus 4 times negative 2 minus 5. Now this negative 2 to the fourth would be a positive 16, but the opposite out front, so that would be negative 16. This would be negative 2 squared, which is 4, times 3 is 12. This is a negative 4 times negative 2 is a positive 8 minus 5, which gives us negative 4 plus 8, which is 4. 4 minus 5 is negative 1. Lots of little places to make an error. Now, synthetic division says, let's divide by negative 2. So we've got negative 1x to the fourth. There's no x to the thirds. There's your squareds. There's your x. And there's your number. So we're going to drop down negative 1. That's a 2. Combine 0 and 2 and we get 2. Negative 2 times 2 is negative 4. Combine we get negative 1. Negative 2 times negative 1 is 2. Combine we get negative 2. Negative 2 times negative 2 is 4. Combine and we get negative 1. This is what your remainder theorem says. If you do synthetic division by negative 2, the remainder is the same as what you would get if you evaluated p of negative 2. Now the factor theorem says the polynomial x minus k is a factor of p of x if and only if p of k is equal to 0. So use that to decide whether x minus 2 is a factor of p of x. If it is, write p of x as a product of linear factors. Now let's back up and see what it says. It says the polynomial x minus k is a factor of p of x if and only if p of k is equal to 0. So if we're looking to see whether x minus 2 is a factor, we want to know if p of 2 is equal to 0. Well, you can plug in 2, or if you like synthetic division, we're going to do it by 2. We get 4x to the third, 24x squared, 48, 32. Drop your 4. There's an 8. There's a 32. There's a 64. There is 112. There's 224. There's 256. So is x minus 2 a factor? No, because the remainder was not 0. Now the number k is a 0 of a polynomial function p of x if p of k is equal to 0. Decide whether the giving number is a 0 of p. Let's back it up and read it. It says the number k is a 0 of a function if p of k is equal to 0. To decide if 2 is a 0 of p, one way would be to just plug it in. So that would be 2 to the third minus 4 times 2 squared plus 9 times 2 minus 10, which is 8 minus 16 plus 18 minus 10, which is negative 8 plus 18, which is 10, minus 10 is 0. I'll say it again. If you would rather do the synthetic division by 2, there's 1x to the third, negative 4x squared, 9, and negative 10. Drop your 1, multiply, combine, multiply, combine, multiply, combine. The remainder of 0, and plugging the number in and getting 0. Okay, let's do this one. What about negative 2? Now see, plugging in this one's going to be rather tough. But if we did our synthetic division, 3 over 2, negative 1, 3 over 2, and 0. So we bring down our 3 over 2. 3 over 2 times negative 2 would be negative 3. That would be negative 4. That would be 8. 3 over 2 and 8. That's 1.5 and 8, which would be, let's see, that's 16 over 2, which is 19 over 2, which would be not negative 19. So is that one going to work? Let's check it. 3 over 2 times negative 2 to the third minus negative 2 squared plus 3 over 2 times negative 2. So that would be, we could cancel this one and one of those, so that would be 3 times negative 4, which is negative 12, minus a 4, minus 3, which would be negative 16 minus 3, which is negative 19. I don't know really which way would be easier. But is it a 0? No, because the remainder was not 0. Now, x-intercepts, zeros, and solutions are really all the same things. Consider the polynomial function p of x. Show by synthetic division that negative 2, negative 3 over 2, and 1 are zeros of p. And then write the p of x in factored form. So if we are doing negative 2 into 2, 5, negative 1, and negative 6, that would be 2, multiply, combine, multiply, combine, multiply, combine. So that means that worked. Now let me show you a shortcut. Let's say we did 1. We could just use this result to do it in 1. So we drop down our 2. 2 times 1 is 2. That's a 3. That's a 3. And that is 0. Okay, now why did that work? Well, let's think if we wanted to factor the number 20. If I told you 2 was a factor, then you would use that to break down 2 times 10. Now, if I told you 2 was another factor, then we could just say, well, we need to do 2 into 10 again, and then the other factor would be 5. Well, let's try negative 3 over 2. We'll drop down your 2. Negative 3 over 2 times 2 would be negative 3. Negative 3 times 3 is 0. So what we got is that these 3 are definitely zeros because the remainder was 0. Now, factored form, if negative 2 is a 0, that means x plus 2 is a factor. If negative 3 over 2 is a 0, that means x plus 3 over 2 is a factor. And if 1 is a 0, that means x minus 1 is a 0. Now, if you don't like these fractions in here, you can multiply everything through by 2, or this factor by 2, and we would get x plus 2 times 2x plus 3 times x minus 1, and that would work. Or sometimes what we do is we just say, well, if that's an x plus 3 over 2, and we know that the leading coefficient is 2, then we could just multiply, and we know that the leading coefficient is 2, then we can just multiply the factored form by the 2. Okay, so either of these would be acceptable. Now, graph P in a suitable viewing window and locate the x-intercepts. Guess where they're going to be? at -2, -3/2, and 1. And then we're going to solve the polynomial equation. 2x to the third plus 5x squared minus x minus 6. If we did that on our calculator, let this side be y1, let this side be y2. You're going to have 3x intercepts, and the 3x intercepts are going to be -2, -3/2, and 1. Now, for the polynomial, at least one 0 is given. Find all the others analytically. Support your answers graphically. And this is what we talked about a second ago. If you know one of the zeros, then we can factor this thing down a little bit and say, well, there's 2x to the third, -3x squared, -17x plus 30. So because this is a 0, then we expect that the remainder is 0. Now remember what the quotient means? If this is a 2x to the third and we're dividing by an x minus 2, then this becomes 2x squared plus x minus 15. Now because 2 was a 0, that meant x minus 2 was a factor. So now what we can do is we can just go through and factor this, 2x and x, 5 and 3. That would give us a +6 and a -1. So this would be considered factored form. Now if you didn't like that, you could look on your calculator and find your zeros and use those zeros to help find your factors. Then it says support your answer on your calculator. Okay, we're going to graph them all in our calculator. We're going to see that they cross at x minus 2 means it crosses at 2. 2x minus 5 means it crosses at 5/2 or 2.5. X plus 3 means it crosses at -3. Now you're ready to complete this section of homework on My Math Lab.